Our research is predicting purchasing decisions of online shoppers using machine learning. And our team consists of myself, Isabella, Shahab, Dorian, T, and Philip. And this is for the class IE4305 under the professor Dr. LeBullock.
So our research was conducted on an online shopping dataset using machine learning algorithms with the goal of predicting a customer's shopping decision when visiting an e-commerce site. We tested 6 models, and the 3 best models were random forest, logistic regression, and SVM. The accuracy scores were 88%, 87%, and 87% respectively. And a little background of why we conducted this research. As we are aware of, global e-commerce sales have been skyrocketing since COVID-19, and with a total of $4.28 trillion in revenue, we think that if a business can predict whether a customer will make a purchase when visiting their website, then they can analyze the data collected from those customers to better allocate resources and advertisement. And that is our goal for this project.
For experimental setup, I would like to start with our dataset description. The dataset included 18 features, including 17 predictors and 1 response variable, which was a Boolean, with a total of 12,330 samples. For pre-processing purposes, we applied 3 different methods, starting with encoding. Encoding was done since the data included 4 predictors in text format and they were converted to numerical values. Scaling was also applied to ensure that the model was not affected by broad range of feature values, and finally, synthetic minority oversampling technique, SMOTE, was applied to the training dataset to add new samples and balance the dataset by adding 6,359 extra samples.
For the experimental test plan, 6 models were tested and the 3 best were selected based off accuracy and F1 score. They were selected for parameter tuning using the grid search CV parameter approach, aiming to improve the F1. 5 parameter values were grid search for each of the best models and a cross-validation of 10 to be used. The first selected model, being random forest, uses the outputs from several decision trees to make a prediction with its parameter to tune being the N estimators. The second selected model, SVM, is used to find a hyperplane, which is an n-dimensional space that distinctly classifies the data points, with its parameter to be tuned being C. The third selected model, logistic regression, which is a predictive analysis algorithm based on probability and uses a complex cost function defined as the sigmoid function or the logistic function, its parameter to tune also being C.
The experimental results show the final scores of the 3 models before and after grid search was applied, and the confusion matrix of the random forest model, which performed the best. The ROC curve represents the performance of the models across possible classification thresholds. Increasing the classification threshold decreases the false positive rate and the true positive rate. Figure 7 shows the blue curve, which is the random forest model, has the highest area under the curve and performs the best.
And to conclude, this project aimed to assist with predicting online shoppers' behavior based off their browsing patterns during a website visit. The 3 best models were random forest, SVM, and logistic regression. The performance of the random forest and SVM models increased slightly after using grid search, and the final random forest model can predict with 88.8% accuracy whether an online shopper will make a purchase when they visit an e-commerce bookstore. For further research, we'd like to find the significant factors that enable the model to predict purchasing behavior. Companies can then use these factors to more effectively allocate advertising resources and thus improve their online shopping revenue stream. And finally, we'd like to thank Dr. LeBullock for helping with this research.